Let's take a look at an example here. I want to find the domain of f of x equals xy over x squared plus xy plus y squared. Now, both these guys are polynomials, so I know that both of these individually are defined everywhere. So the only consideration is when is this equal to 0. So I need to think about when x squared plus xy plus y squared equals 0. So really the domain will be all xy such that x squared plus y squared, x squared plus xy plus y squared is not equal to 0. Well, the only time that this is going to happen when I do have 0 is if both x and y are 0. If x is 0, I'll have y squared. If y is squared, I'll have y is 0, I'll have x squared. So I need them both to be equal to 0. So I know I'm going to have this function to be discontinuous at the point 0, 0. But now my next question is, what's the limit? Does the limit exist? So I want to take a look at the limit as x and y both go to 0 of xy over x squared plus xy plus y squared. Does this limit exist? Well, I'm going to take a look at this from a couple of different angles. First, I'm going to let y equal 0. Let's call this approach 1. And now I'm looking at the limit as x goes to 0 of f of x 0, which is 0 over x squared, which equals 0. So the limit as y equals 0 along the x-axis is going to be 0. So now I'm going to take another approach here. I'm going to let x equals 0. So I want the limit as y approaches 0 of f of 0y. And when that happens, I'm going to end up with 0 over y squared, which is also 0. So it's kind of starting to look good, like it might actually exist. Let's try another approach here. I'm going to let y equal x. That's just another path. So I want to take a look at the limit as, well, if y equals x, I'm going to do this all in y's. So this is a limit as y goes to 0 of, I said y goes to 0, then I wrote x. So, okay, so I'll do it as x equals y. So, or y equals x, good. So this is going to be x squared over x squared plus xy, whoops, y is equal to x, so that it is going to be x squared plus x squared. So this is a limit as x goes to 0 of x squared over 3x squared, which equals a third. A third, there we go. So I have this limit, this path taking me to 0, this one taking me to 0, this one take me to a third. Therefore, the limit as xy goes to 0, 0 of, x squared plus xy plus y squared D&E. This limit doesn't exist, because I was able to get to two different limiting values by two different paths.